Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. I welcome you all. Thank you very much. Thank you everyone for joining in. Now the session today is on Onyx. It's a graphical interface for structural equation modeling. And what we'll do today is we'll start with what is SEM, what is confirmatory factor analysis, concept of measurement and structural models, using Onyx to build basic measurement model, building simple regression model using Onyx, and building complex structural models in Onyx. And finally, assessing scale reliability and establishing construct validity, that is both convergent and discriminant validity. Now, my profile, my name is Fawad Latif, and I'm working as assistant professor in Department of Management Sciences, Comsets University, Islamabad, Atak campus, Pakistan. I have some experience with research. I've published some papers in good impact factor journals. The journals that I've primarily published are corporate social responsibility, environmental management, social indicators, total quality management, business excellence. Recently, I've published in International Journal of Hospitality Management and Studies in Higher Education. Some of the techniques that I know are SPSS, Smart PLS, AMOS, R, Onyx, IFSQCA, Atlas. You can search me on Google Scholar by writing Fawad Latif, and I'm on Publons as well with the same name. Just type in. Thank you. So what are the contents? Again, SEM, confirmatory factor analysis, measurement and structural model, using Onyx to build basic measurement model, building simple regression models in Onyx, building complex structural models in Onyx, assessing scale reliability and establishing construct validity. So starting with, what is SEM? What is structural equation modeling? Now, structural equation modeling is a multivariate statistical technique. This means that it will involve more than two variables that is used to analyze structural relationship. This technique is a combination of factor analysis and multiple regression analysis. So it is not something that is different than regression analysis. The models that we are building are actually based on regression analysis. And it is used to analyze the structural relationship between measured variables and latent constructs. So we all have seen these models, where we have got these latent constructs, there we have got these indicators. So Onyx will also help us, let us build these models, just as we build these models in AMOS, M+, or R, or Stata. So what is CFA? Confirmatory factor analysis has become established as an important analysis tool for many areas of social and behavioral sciences. So SEM is your umbrella term. And in SEM, the number of different techniques are performed. One of them is CFA. It belongs to the family of structural equation modeling techniques. So in structural equation modeling techniques, you can have number of different techniques. One of them is CFA. And what it does is it allows the investigation of causal relationship among latent and observed variables in a priori specified theory-derived model. So you have a model and you know this is how the relationship should be. But you want to check whether your assumption, your assertion that you have a priori expected is actually true when you get the data. So these softwares, this structural equation modeling technique, this CFA helps you identify and establish whether what you specified, whether what you wanted to test is actually true based on the data that you have collected. Now, the main advantages or the main advantage of CFA lies in its ability to aid researchers in bridging the often observed gap between theory and observation. So this is what the theory told me, and this is what the actual observation is. So you can relate the theory with the observation that you get from the data. And furthermore, you can test whether the model that you have proposed actually fits the data or not. This was not available in first generation tools like SPSS. So you could not establish fits in SPSS. So there are two types of models that you build in structural equation modeling. One is measurement model and the other is structural model. The first model that you build is your measurement model. The measurement model is part of the model that examines relationship between the latent variable and their measures. So the latent variable which is unobserved and the indicators through which that latent variable is observed. So what's the difference between the two? Let's say I want to judge the employee commitment within an organization. So I ask them these questions. Do you believe in the objectives of the organization? Would you like to go an extra mile for the organization? Would you leave the organization if you get another opportunity? Now, in order to measure organizational commitment, what I have done is I've asked 3 questions. The respondents are actually answering these 3 questions. They are not answering organizational commitment, but these 3 questions are actually helping me measure organizational commitment. In this case, the observed variables are the one I am asking questions on, whereas the latent variable is organizational commitment, because that organizational commitment variable is unobserved and it's only measured or observed through asking these 3 questions. So in measurement model, you are establishing relationship between the indicators, the measures, those 3 questions, and the latent variable, which is organizational commitment. And you establish whether these 3 questions actually measure or support or actually help us measure the underlying construct or not. So measurement model helps establish the reliability and validity of the construct. So you do measurement model to establish the quality criteria of your constructs in this study. And unless or until your measurement model is good enough, you cannot go for a structural model to test the relationship. So if your variables are not measuring what they are intended to measure, so if your scale that you have developed, designed, or adapted or adopted is not measuring what it was intended to measure, then it is not adequate to go ahead and test the relationship, because it will not give you the correct results. So the first step is your measurement model. The next step is, once your measurement model is complete and you have established the reliability and validity, the next step is your structural model. Now, based on the theoretical framework, researcher assembles the validated latent constructs, those that are reliable, those that are validated, valid. Links are established between the exogenous constructs to endogenous constructs using single-headed arrow. Now what you are doing is, I've established that yes, these 3 items can measure organizational commitment. These are reliable. This construct, this measure is reliable. And I have the intent to look into the impact of organizational commitment on organizational performance. And organizational performance is again measured by 3 or 4 indicators. So this is not possible in measurement model. So this is not part of measurement model. Now, in order to assess the impact of organizational commitment on organizational performance, I will have to build a structural model, whereby I draw lines, arrows going from your independent variables to your dependent mediators or other variables. In simple terms, structural model is to test your hypothesis, whereas measurement model is to assess your reliability and establish the validity. So what is Onyx? It's a free software for structural equation modeling, for creating and estimating structural equation models. It provides a graphical user interface that facilitates an intuitive creation of models and powerful backend for performing maximum likelihood estimation. So there are different estimations available in SEM. AMOS uses maximum likelihood, and Onyx also uses maximum likelihood. There are other estimation, but that is not part of this session today. Now, starting Onyx. How do you get Onyx? So let's see if any problem. Okay, no problem. So here is this website, onyx.brandmeer.de. So it's a Dutch website. So what you can do is, in order to get to this website, if you don't remember the name, I'll also copy it in the chat box. You can search Onyx SEM Onyx SEM in Google. Just write Onyx SEM in Google and you will have the software or the website. So moving on. So let's I've already downloaded it. It's a executable file. So just download it and you will be able to run it right away. There's no installation or whatsoever. So I've got this Onyx 1.0-1026. So what you can do is once you click download, it will take you to its download page. And yesterday I contacted one of the developers who's a professor in a university, and he said that they have applied for funding to further develop this software because the last release was in March 2019. So you can use this developer release because it works fine. I've used it. So they are saying they have applied for funding, so hopefully soon we will have much more of Onyx, much more details, much more analysis. Some of the things I mentioned to him that should be incorporated, so hopefully those things will be incorporated as well. So just download this developer release and you will be fine. Now moving on, let's see. Okay, so how do you run it? Once you have downloaded it, it's an executable file. Just double click it and it will run right away. So what you will see is you will see this empty screen. So the first thing that you do is, in any software, you load the data. So let's first load the data. Here is the sample data that I'm going to use, and before going into the detail of how to build the model, I'm going to tell you what model we are going to build today, because this is particularly important. Most of the time when we have collected the data, but we do not know where to go from here. So it's a very simple model. So for let's say this is the model that I'm interested in. This is the model that I want to build. So how am I going to build this model in Onyx? So let's start with very basic of Onyx. So once I've got the data, you can import in SAV or the SPSS file. You can import CSV, Excel. So that's not a problem. So my data has got 221 observations and 64 variables. It's a quite big data set, so your fits might not be that good, but that doesn't matter. We are just learning here today. So the next step is, once you have got the data, the next step is click this Onyx and create an empty model. The next step is, I'm going very slow, so you can if you want to take some notes, what I would suggest is just watch the video for now. If you want to take notes, sure you can, but then you might not be able to keep pace with the software. So just watch the video. I'll upload a very edited version of this video that you can watch later and take notes, and then ask your questions again through my email or the Facebook page, and I'll try to answer to the best of my ability. Thank you. So let's create a basic or simple model. So what you do is you click Onyx. It has got just one menu, one simple menu. The other menus are within the model. So you click create empty model. So what it does is it gives you an empty model. This is the empty model, and here is a little message box that gives you the messages while you are working on the model, error messages and other messages as well. So let's if you see these three lines here, you can extend the model as well. It is an unnamed values with nothing, or it's looking for starting values to start the model, because there is nothing on the model. So it will keep displaying starting values for you because there's nothing in the model. So let's enlarge this model a bit. Through these three lines, just drag them and you'll be able to enlarge it. Now I'm interested in building a very simple model with one single construct. That's about it, nothing else. So what I do is I click on 81, and then using the shift and down arrow, you can select the indicators. Now when using SEM, each of your latent construct has got its own individual identity. So let's put all these items that are relating to authenticity together from 81 to 85. After the selection, just click on them and drag them onto the model. So once you have selected them, just click on them and drag them onto the model. And what you will see is, you will see these 5 indicators loaded, 81. And once you like hover your mouse on this, you will see the minimum value, the first quartile, the median, the mean value, the third quartile, the maximum value, standard deviation, the total indicators, and the R square is 0, obviously, because we haven't put in the latent construct or made any relationships. Same for 82, 83, 84, 85. Now this is your error variance, which we normally get as an E in AMOS. So let's say we've got this indicator. Now these are observed variables for authenticity. Now in order to draw a latent construct, what we will do is, in order to add this latent construct, what we do is just right click on the on this white space here and click create variable. And once you click create variable, click latent, because you are interested in drawing the latent variable now, one that is unobserved, observed through these 5 indicators. So authenticity is observed through these 5 indicators. So how would I tell that, okay, this is a latent variable and these are the 5 indicators? So you have to draw the latent variable. So go to create variable and click latent. Now this is your latent variable and here is your error. Obviously we haven't done anything, so that's why. Now how would I tell this program or any program that the indicators for this latent constructs are these 5 variables? So what you can do is, you can move it around from here and there. What I would suggest is, in order to make it more suitable for movement, you can go to customize model, change grid properties and lock to grid. This will make the movement easier. So just display the grid, it's always a good idea, and lock to grid. So what you need to do is how to link this. So what you can do is right click on it, right click on the latent variable and drag without dropping the mouse, without leaving the right click. Just drop the cursor or the arrow onto your latent constructs. So right click, drag and drop onto the latent construct. Right click and drag onto the latent construct. Similarly for the next, and similarly for the last one. So what you do is just right click on the latent construct and drop it onto the indicators. So now that you have drawn the model, the next step is in this Onyx is that you fix the parameters for your latent construct. In other softwares, what we do is we fix the parameter for one of the indicators. So it serves as a reference for other indicators. In Onyx, what we do is, instead of fixing the parameter for your identified or observed variables, you fix the parameter for your latent construct. Now in order to do this, what you do is you simply click on this covariance, this double-headed arrow, just right click on it and fix parameter. So now the parameter is fixed, and the next step is, in order to assess your model, select these arrows. You can select them all together by just dragging and dropping the mouse on them, and right click on it and click free parameter. Right click on these arrow, one of these arrow after selecting all these, and click free parameter. Now once you have clicked the free parameter, the next step is, because it shows you unstandardized estimates, so what you do is just right click on it and click standardized estimates. So it gives you standardized estimates that we normally, this is the standardized estimates in this case are your loadings, factor loadings. So, and obviously all calculation that we do or that we will do later will be based on standardized estimates. So you click on standardized estimates, and within these brackets now you can see the standardized estimates. Okay, so here are our standardized estimate for each of the variable in the model. Now this is your basic simple measurement model. Now what we've got here is we've got the loadings for each of the indicators. Its loading is 0.64, which is over 0.5, so all good. This is 0.86, 0.62, 0.73, 0.65. So overall we could say, well, it's sort of fine. Now the next step is, whenever you are building your structure measurement model, the next step is, once you have assessed the loadings and the loadings look pretty fine, the next step is to see if you can delete some loadings or low loadings. In this case, for now, let's keep all the loadings, and once we go on and calculate our average variance extracted or our composite reliability through our calculators, we'll see that whether or not we need to delete any of the items. So this is how you build a very simple model in Onyx. Now moving on, let's say, and we are using maximum likelihood estimate, the best. So if it doesn't show like this, what you can do is you can go to estimation and show best ML estimate. Just right click on it on the screen here, on this any of the empty area in the grid box, click estimation and show best ML estimate. So it will show you the best ML estimates. Now you want to see the output, you want to see whether or not the data fits this particular model or not. So because this model here will only give you the loadings, so what you can do is you just right click on it and show estimation summary or show estimate summary. So in order to get a summary or output for your data or results from your data, you right click on this empty area and click show estimate summary. And once you get here, it will show the descriptives first. You can obviously extend it. It will give you the estimates, unstandardized estimates. The standardized estimates, you can get it from here in the graph or in the model. Moving on, we are now interested in establishing the fit, the model fit. So we have a number of different fit indices that are provided by the softwares. The most common that we normally use are provided here. We go for RMSEA, which is 0.1. It is actually high. It should be less than 0.08. Preferably, it should be less than 0.06. But other indicators of fit are good. SRMR is pretty good. It's less than 0.06, 0.05. CFI is greater than 0.95, which is good. TLI is greater than 0.90. It is acceptable. So more or less, it's quite good. But if you want to further improve it, what you can do is you just right click on it, close script, and let's say if we remove this, because this is less than 0.60, this 84 is less than 0.60. So let's say if we keep the threshold to 0.60, the loadings. In SEM, we normally ask for 0.70. In SEM, we normally ask for 0.60. So in SEM, we normally go for loading that should be higher than 0.70, but we normally, if it's even 0.60, we keep it because most of the items or other items might have over 0.8. So cumulatively, they might serve or establish the average variance extracted. But in this case, let's remove this loading, just this indicator item. So once this is removed, we can go back and look at the estimate summary again and see if our fit improved or not. In this case, we expect it to be improved. So if you go back and we look here, okay, it's showing not a number, and it's just hold on. So you might encounter this error where it shows not a number, not a number, not a number. So how do you solve this problem? Let's close it. So now, how did I solve this problem? Sometimes what happens is that it gives you NaN, not a number. So what you need to do is just right click on the data or your data set here and send it to the model again. So once you send it to the model, this error goes away. And now look at this model. Now let's see. Now the problem is your CFI improved, your SRMR, well, it's more or less the same, but your RMSEA did not improve. Actually, it was made worse. Same is the case with TLI. So this shows that you have to be very cautious when deleting items. It might create problems for you. So now what we have to do is we have to put that item 84 back again, because this was creating problems. So you can obviously right click, add regression, and do it like this as well, or otherwise just right click on it and drag it onto the indicator, and you can free the parameter, because this is how it should be. Otherwise it will not give you the loadings or proper loadings. So now this is how you build a very basic measurement model in Onyx. Now moving on, let's say, and if you have got multiple indicators or multiple latent variables, as in this case, how would you do, or how would you make multiple latent variables in a single model? So let's arrange it a bit so we can add more variables to it. Now this, let's add another one. Let's add this one. So this is the second latent construct, and all these 6 latent constructs from AT, BE, DP, EH, humility, HM, wisdom, W, all these 6 are actually measuring servant leadership. So in my study, servant leadership had 6 dimensions. So what I'm going to do is, for now, just add another one. Similarly, you can add the third one, fourth one, fifth one, sixth one, how many you have in your own study. So now this is added. Let's rename it. So what, just like right click on it and you can rename it here. So this was 80, so now renamed. Now we have to, these are the indicators for DP. So let's add the latent construct, fix its parameter to 1, or fix the parameter, the starting value is 1. So once it's fixed, drag and drop the arrow onto the indicators. So this means that DP is measured using X2 for now, because we are going to rename it. Just right click on it and we rename it as DP. Development. Okay, let's arrange it. Now, since Onyx is a covariance based structural equation modeling software, what you need to do is you need to covary these two, because they are actually measuring the same construct. The first thing is obviously they are correlated with each other as well. So how do you correlate them? Because otherwise, if you go to your estimate summary, what will happen is you will not have proper results. See this? The loading is, CFI is very low, TLI is low, SRMR very high, it should be less than 0.06. So what you need to do is you need to covary these. So when you are making or developing a measurement model, what you do is you put all your latent variables with their indicators and you covary each of the latent variables together. There is no single headed arrow, because this is a measurement model, not a structural model. So when you are doing your measurement model, what you need to do is put all your latent constructs in your study. In this case, I will have to put in the DP and everything. And if you are developing your measurement model, just correlate, draw double-headed arrows of each indicator or each latent variable with the other latent variable. I'm going to do like add another latent variable so you know. So let's right click on it, add path and add covariance. Right click, add path and add covariance, and drop it onto the other indicator with which you want to draw covariance. And once this is done, This is the double-headed arrow, the covariance is drawn, and if you go back and if you have a look here, still it's not that good actually. Anyways, the data, because there are too many indicators, so that the problem is with the data anyway. So just right click, send to data, just to be sure everything is fine, and just select these indicators or these lines from the latent variable to the indicators. Right click on it, right click while it's selected and select free parameter. And if you want to show standardized estimates, because those are the loadings that you are going to use later, select it, right click and show standardized estimates. The loadings are pretty good. Next step, let's add another variable and see how you can correlate all these three. That I was saying that in measurement model, what you need to do is you need to correlate each of the latent variables together. So let's draw the latent variable. So first step, create latent. Let's click this double-headed arrow, fix the parameter, and from here draw the lines to the indicators. Just right click and drag, just right click and drag, right click, drag, right click, drag, right click and drag. So once you have dragged and fixed the parameter, the next step is select these lines, these indicators lines going from the latent variables to the indicators. Once all of them are selected, right click on it, click free parameter, and then right click, show standardized estimate. Once this is done, the next step is, you can't leave it alone because this is your measurement model. What you need to do is you need to correlate this variable, which is, right click, let's rename it EH, and what you need to do is you need to correlate this with the other two latent variables. So each of your latent variable is correlated with the other latent variable. So what I can do is I can right click on it, add path, add covariance, and link it to this. Right click on it, add path, add covariance, link it to this. Now I think each one of them is linked to the other. In order to be sure, what we can do is we can arrange it a bit. That will make it pretty easy to understand, just as we do in Amos. Now if we have a look, we can see that each of the variable is linked with the other variables. There is covariance between all the variables. So this is how you can draw your measurement model. In this case, you will have to add all these latent constructs onto the model and link each of the latent constructs, and then go to your estimate summary and look at its loading, showing it's saying that starting value set, so it's calculating. So if it takes too much time, just to be sure, just send the data to the model and just wait, and it's calculating, because it's saying here model parameters are being estimated right now. So they are estimating the model parameters, but an important thing here is just you have to free these parameters as well, otherwise your results won't be any good. So just free these parameters and show standardized estimates. All these covariances must be freed, and right click, standardized estimates, right click, show standardized, right click, show standardized, free parameter, right click. Okay, it's already done. Let's move it a bit here so that, okay, all done. Okay, now the problem. Why is it not showing this? So let's see the problem. And if you look here, this is the problem. There might be some problem with the data. So what we need to do is we need to delete these two items. So delete this and delete this. And let's see our problem is solved. Yes, our problem is solved. Just to be sure, estimation and best ML estimate and mean structure, this should be saturated. Dataset clone. Oh, sorry. Yes, dataset to the model. Yes, this is the model. And yes, it looks fine now. Let's do a basic regression model. So here is the data set again, and in order to do a basic regression model, let's do, what I've done is I've already transformed the variables. So I'm interested in assessing servant leadership and its impact on, let's say, life satisfaction. So very simple linear regression. Simple linear regression, impact of one IV on one DV. So what you need to do is, once you have added these indicators, this is the composite measure. This composite measure is calculated based on, so servant leadership is based on all these indicators actually. All these indicators summed up together. Life satisfaction based on these indicators rather than summed up, actually mean. So what I've done is I've taken mean of these for in Jamovi basically. And so in order to transform the variable, there's a video on the channel how to compute variables or take mean score, and I've taken the mean scores for these 5 indicators for LS. So I've got SL here and I've got LS, life satisfaction, here. In order to draw regression or do basic regression, what you need to do is, there is a line that will go from the independent variable to the dependent variable. So what you need to do is just right click on it, add path and add regression, or otherwise same thing, right click and drag from your independent variable to your dependent variable. The next step is right click on it, free the parameter, so it estimates the parameters. Right click on it, show standardized estimates, so it's showing you standardized estimates. The next step is, in this case, what we do is we do not have this error variance like this with the dependent variable, so we remove this double-headed error variance, and what we do is we add a latent variable serving as the residual. Edit, fix its parameter, and then draw an arrow from this latent construct to your dependent variable, and then right click on it and free its parameter, right click on it, show standardized estimate. So this is how you can do a simple regression analysis in Onyx. For instance, you want to add another variable, so just drag and drop that calculated variable onto your canvas, and let's draw again an error term from, but what we need to do is we need to remove this error term from the indicator or from the measured variable, and right click and add an indicator or line from your latent variable to your mediator. In this case, let's say this is a mediator, and then servant leadership is influencing self-efficacy, self-efficacy is influencing life satisfaction. The next step, free the parameters, and you will get the standardized regression weight or coefficients. This is 0.56, this is 0.48, this is 0.3, and you need to free the parameter here as well, and that's all, looks all good. The model is over specified, that's not a problem because we haven't got the indicators. Now if you click here, there was this button here right next to this canvas, and you can export it as text or export it as HTML. So how do you interpret these results? So in order to interpret these results, just fix the parameter. Okay, now we are interested in evaluating whether servant leadership influences self-efficacy or servant leadership influences life satisfaction. Now in order to do this, what you need to do is just have a look here. Servant leadership and life satisfaction. The Z value is 5.99, which is calculated based on the division of estimate with standard error. This is your T score, T value, which is a test for, or which can help you ascertain significance of relationship. It won't give you P values. Onyx will not give you P values, so you will have to resort to Z value and interpret them. In this case, servant leadership and life satisfaction has a Z score of 5.99, which is greater than 1.96. So this means that the relationship between servant leadership and life satisfaction is significant. Same, you can check SL and SE. Servant leadership and self-efficacy is also significant because it's greater than 1.96. Same is the case of SE with LS. It's self-efficacy with life satisfaction. The Z score is 11.18, which is greater than 1.96. So all three relationships here are significant. All three relationships here are significant. But now Onyx will not give you indirect effects. Onyx will not give you mediation results. So how do you calculate mediation in this case? So what you need to do is, there is a simple calculator, and I'll share the link as well. This is free indirect mediation effects calculator by Daniel Super. So let me copy this link and send it to you. I'll answer the questions in the end. Okay, here is the link to the calculator. So these are what it requires. This software or this calculator from you is your A estimates and your standard error. So in this case, let's put in the estimates. So let's put in standardized estimates. 0.48 is your A. So this is your A right here. SLSE, this is your A. SELS is your B, and SLLS is your C. I've just named the paths. So SLSE is your A and the estimate is 0.48. So what we'll do is we'll put in 0.48 here. Your B is 0.56. So let's put in 0.56 here. Your standard error for A is SLSE 0.07, and your standard error for B is, which is SELS. So SELS standard error is 0.05, and we see that the indirect effects are significant or not. So you press just calculate and it's calculating. So indirect effects is 0.26. So it's if you multiply A into B, you will get the indirect effects. And at 95% confidence interval, it is insignificant. So it's showing that because there is a zero in between, this is minus and this is plus. So there is no mediation in the, or what you can say is SE does not serve as a mediator between these two, between SL and LS. Now moving on, the next step is, okay, this is how you do a simple regression model, and furthermore you can use Daniel Super for mediation. Okay, let's try with estimate this 0.57, which is your SLSE 0.63, and 0.57, 0.63 and 0.57. So we know that because 0.64 and 0.57, calculate. Okay, it's still insignificant, so we were right, because they haven't mentioned that they want standardized or unstandardized. So we've checked with both, so the results doesn't change. So there is no mediation in the relationship between servant leadership and life satisfaction by self-efficacy. So the hypothesis is rejected. So now we have done our measurement model, and now we have done basic regression modeling and how to test mediation using Daniel Super through Onyx. The next step is building a more complex model. Let's make a more complex model with second order or higher order constructs. So let's say we've got these indicators, and let's make a few. Let's say we've got this DP here, which is a latent variable, a sub-dimension of servant leadership. And let's right click, create variable, latent, fix the parameter, and then draw the indicators. And next step, free the parameters. Just select all arrows by dragging your mouse. Just click free parameters, and let's estimate the standardized estimate or show standardized estimates. Now this is one. So this is how you just like double click on it and it will show, double click on it and it will hide. And let's say we add EH ethics. So EH1, EH2, EH3, EH4 and EH5. Let's add the latent variable as well for this one. Just right click and put the arrows in here. Fix the parameter and select these arrows. Free the parameters, select again, standardize estimates. Just hold on, and we'll add the third one. Let's add humility. So just creating a bit of space here, and so HM1, and then obviously add the latent construct. Right click, draw the arrows, fix the parameter, select these arrows and show standardized path. And now if you look, there's this error. All the loadings are 0.71. So free parameter, yes. So why is this error? Because we haven't drawn any covariances. But in this case, we are not drawing covariances. What we are saying is that these three latent constructs are actually sub-dimension of another latent construct, second order construct. So just right click on it, fix its parameter, and this is servant leadership, and this is development, this is EH ethics, and this is your HM, humility. And now what you do is, in order to draw second order construct, the same thing what we did with the indicators. Now servant leadership is reflected in development, servant leadership is reflected in EH, servant leadership is reflected in HM. Now this is your second order construct, or servant leadership measured through these three sub-dimensions. Next step, select these three lines, right click on it, free the parameters, right click on it and show standardized estimates. Now still there is error. Why is this error? Because of this. Earlier I mentioned that sometimes there might be problem with the data and you will get this error. So what I need to do is remove EH3 and remove EH4. You can go back into your data, look for Haywood cases, look for the data, any data entry errors or anything, look for outliers. And what you need to do next is select this data, put it into the model, and estimation, show best ML estimate, and make sure all these are free, no sorry, fixed, 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 this is free, right, free, right, this is free. So it's starting values, it's calculating, so you might have to wait a little. Meanwhile, I can open the other model that I built, similar model. So Onyx, load model and data, and complete model. So similar to that model, I actually built this model. So it's more or less similar, or actually similar, but in the previous example in here, what I did was I only included 3 indicators. But in this case, what I've done is I've added more dimensions. Okay, let's go here. Now see, this is the complete model, and you can see all these loadings here, everything. And just to be sure, just send the data to the model, the complete model, and it is starting value, so it's calculating. And it has got the maximum likelihood best estimate. And in here what I did was, this is your second order construct, your SL. In order to make it clear, what you can do is you can customize your models as well. Apply diagram style and let's say go for default. So this is your default, and all these are this is your second order construct, SL. So just rearrange it a bit if you want. So what I've done here is, this is your second order construct, servant leadership, just as you built in the model, and this is measured through 6 dimensions. Some of the items might be deleted because of errors or problems or with the loadings. So this servant leadership is now influencing self-efficacy here, and the dependent variable is life satisfaction here. So this is your mediator here, self-efficacy. So this is your mediator, and if you want to test the mediation, obviously you can use the similar technique that I mentioned earlier. One of the problem is whenever you load the data, you will have to go again, show the standardized estimates. Show standardized estimates, show standardized estimates. So this is one of the problems with Onyx, because since it's in a developing stage. Now we want to test or check our hypothesis. So what you do is just double click on this thing here, or right click here, show estimation summary, and it will give you all the estimates that you want to check. Let's say what relationships were significant. Now if you see this, it has given this a path name x7 to x8, so it's not counting it as SL or LS. So this is the path. Now whether or not this path is significant, what you need to do is you need to go to x7 to x8, which is this one here, this one selected. So this path is significant. 4.55 is your t-value. So in order to test significance, or in order to find out whether this path is significant, what you need to do is just right click on the path, and you will see that this is the path name. So the path name is x7 to x8 because we changed the variable's name later, but it was not changed here in the path. So go to x7 to x8, and here it is, x7 to x8. Here is your estimate, here is your standard error, and z score is your t-value calculated by dividing the estimates by standard error, and you have 4.55 as your t-value, which is significant. So this shows that the relationship between servant leadership and life satisfaction is significant. Let's see the other one. This is the path x7 to x9. So where is x7 to x9? Right below x7 to x8. This is also significant, 8.00. Let's look at the other one. Right click on it, and the path x9 to x8. So where is x9 to x8? Here it is in the end. So this path is also significant. So all your paths are significant. So this is how you can check the paths as well. Now the next step is we are going back a little on to let me see if I've got like any confusions here or any questions. Okay, moving on. Let's close this, and now this is how you can build second order factors and develop further relationship between variables, and you can check your mediation by using these estimates, put it in this Daniel Super calculator, and if it does not have a zero in between, the results are that yes, there is mediation, but in this case there is a zero in between the variables, the indirect effect. So in this case we cannot say that there is mediation. Now you can also do moderation. Just calculate the Z scores, and once you have got the Z scores, you can use and do simple moderation. There are other ways to do moderation with indicators, but that will require creating interaction effects and orthogonal or mean centering, or there are different techniques for moderation. I hope I can do a video on moderation using Onyx soon, a complete video on moderation using Onyx and Onyx, sorry, and hopefully soon I'll share that video as well. Okay, now this is done. The next step and the final step today is assessing reliability and validity. Now let's see the model fit as well. If you go to the estimation summary, let's see the model fit. Won't be great because this is just a sample data, but it's quite good enough. 0.859, 0.849, RMSCA less than 0.08, RMR not so good. Now how do you improve model fit in this software? The developer told me that you have to look for R square values. Low R square values should be deleted. So any loading less than 0.6 or 0.5, look at your model and see if you're not deleting too much. So any loading less than 0.6 may be deleted, and then you will have a more good model fit. Otherwise, what you can do is you can get modification indices from other softwares like Jamovi. Do a CFA in Jamovi. There is a video on the channel on skill development, and we did CFA in that video. So do a CFA in Jamovi, and you get modification indices, and use those modification indices to draw covariance between these indicator variables. So how do you draw covariance between these indicators variables? Just right click on these variable, add path, add covariance. So if there is a modification indices too high between two variables, you just covary them. So, and this is allowed. So this will help you improve your model fit as well. Okay, moving on. Let's assess the reliability and validity. So let's close this model, right click. Oops. So if you iconify by mistake, just double click on it and it will obviously get back. So just close this model and let's open another sample model that I have. And sometime remember that the estimation might take time. So don't be afraid and do check that error that I've mentioned. And sometimes you do not see the values or starting values, so just or the data set it doesn't start or doesn't show the estimated value. So just right click on this data set and send your data to your model and your problems will be solved. So load data, let's say we've got this sample model here that I already done. Let's see this. Okay, now this is a sample model that I did. So it has got some indicators here and indicators here. Both of them, these dimensions are actually, these two are the dimensions of servant leadership. Servant leadership is influencing life satisfaction. But in this case, actually we are looking at the measurement model because we are trying to assess the reliability and validity. So let's delete this. Let's remove this. And it's always a good idea to see this is starting values, so it's not starting anything. So even if you click on show estimates value, it will say that okay, yes, it is starting, but it won't start. What you have to do is right click on it, send data to second order factor, and you will get the results right away. So this is something that you might have trouble with because I had trouble with it. So anyways, now see with these two indicators, the loadings are good, the SRMR is good, RMSCA not good. Anyways, you are not interested in this. What we are interested in is establishing the reliability and validity. But when we assess the reliability and validity through measurement model, we look at each of the latent variables. So just remove this, right click on this, add path, add covariance, and let's see this. So let's say we have got 2, 3 or 4, any number of latent constructs. So in here, so I've got this calculator and it's already shared on the website. So I'll share the address to the website again. And let's see, we've got these calculators here. And let's calculate our composite reliability, average variance extracted, correlation, and see the discriminant validity as well. So we are going to do all three forms of validities today using Onyx. So if you are new to Onyx and you might have trouble in the start, but it will work fine. Okay. Okay, this is the calculator for average variance extracted. Okay, thank you, Alfred. Do watch the video later. Okay, now this is the model and these are the loadings. No, these are not the loadings. As I told you, you have to go back again, show standardized estimates, and the loadings are always in the bracket. So just make sure that you do not do this mistake. Show standardized estimates. Yes, now these are the loadings. So what we can do is let's use these loadings to calculate composite reliability first. And let's put these loadings in here. And where are these? Okay, so 0.27, very low, 0.23. Anyways, just for testing phases, it's just a sample data anyway, just to understand the concept of how it works. 0.27, 0.23, 0.15, 0.27, 0.23, 0.15. So 0.27, 0.3, 0.15, and 0.21, 0.33, 0.21, 0.33, and this is not. Yeah, so your composite reliability in this case is 0.32. It's very low, but the objective is just to understand how to calculate it. The calculator is available on the website. The link will be shared. And similarly, you can do for the development dimension as well. But let's say we are interested in the okay, let's remove it. Why not remove it and add something that would make more sense? And let's put W, so that we can make sense out of the data anyway, since we are putting this much effort and running it. So let's again add a latent construct, and then right click, fix the parameter, and draw the arrows from here, from latent to the indicators, and just covary these, because if you don't covary, the results won't be good. And then click here, select this, right click, free parameter, right click, standardized, and we are having trouble. So let's see how we solve this trouble. Right click, send data to second order vector. Okay, so this is 0.77, 0.72, 0.7, 0.66, 0.7, 0.73, 0.73, and the other one is not that bad actually. So let's put this one first. So 0.72, 0.77, so 0.72, 0.77, 0.7, 0.66, 0.7, 0.66, 0.7, 0.73, 0.73, and the last is also 0.73. And right click, free parameter. This is something I think we made a mistake, and standardize estimate. Yes, this is a mistake. Obviously, let's learn from our mistakes. Always free the parameters where they are required fixed. I've already told you, when you add the latent variable, just these double-headed arrows will be fixed. These will be free, these will be free, this will be free. Otherwise, your loadings will suffer, just as the case was. And now the loadings are fine. 0.78, 0.85, 0.78. So I'm just going to quickly add it because it's taking time now. So let's add it. Just 7478. So now your composite reliability for this wisdom construct is 0.92. Similarly, you can calculate it for your DP as well, your development construct as well. But now let's move on and calculate our average variance extracted. So the same loadings, just copy them into your average variance extracted calculator, and the AVE for wisdom is 0.62. Obviously these are not part of this study, so just remove this and remove this as well. And let's do the other one as well, because we will need to use this for our discriminant validity. So 0.81, 0.86, 0.87, 81, 86, 87, 81, sorry, 87, 81, 83 and 69. Now we've got the AVE for development as well, 0.65, and the square root is this. Now what's the correlation? Now in order to test the discriminant validity, what you need to do is just add, let's say, wisdom here, let's add development here, and wisdom here, development here. So wisdom, the correlation is 1, development, the correlation is 1. So what's the relationship between wisdom and development? It's 0.7. Standardized estimates is, standardized estimate is 0.7. The covariance score is 0.7. In order to be sure, just make sure that you have done this. So best level estimate, just make sure that you have right clicked on it and send the data to the model just to be sure. Estimation, best estimate, and it is, yep, it's fine. Let's so it's 0.7, 0.70. But how do we establish discriminant validity? So what we need to do is, what's the square root of AVE for wisdom? It's 0.78, 0.78. This one goes here. What's the square root of AVE for development? So it will go into the development cell where both the rows and columns for development intersect. So it's 0.80. Now discriminant validity is established if this value, the square root of AVE for a particular construct, is higher than its correlation with all the other constructs in this study. In this case, we were just doing the sample data. Yes, this is high. So the correlation is between wisdom and development is 0.7, but the square root of AVE for wisdom is 0.78, which is higher than the correlation of wisdom with development. So your discriminant validity is established. Now this is how you can use Onyx for your estimations, for your SEM, for everything that you are looking into. Now some of the problems that you might encounter with this software is that doing or running the estimates again and again just to be sure that it's running them, and a few other things, just sending this data to the model every time you make the changes to the model, because sometimes there are these issues. Otherwise, it's a very good software to use, something that is a very good alternative to AMOS, and the results are similar. I've already checked it with AMOS and other, so the results are same, the loadings were same when I checked it with the model, so that's not a problem. There is because it's the technique, it's not the software, although functionality wise it's a bit limited because obviously they are working on the fundings, that I was told. Otherwise it's a good software to use. I hope you enjoy using the software. You might encounter some problems or troubles, but these little problems that you have, that for example not encountering or not calculating the free estimates, not fixing the parameter, and then all your loadings look very bad, so things like that, and otherwise it's a very good software. I hope you enjoyed this Onyx software. I hope you enjoyed watching or like using this software, and I hope you will use it. I hope we see a new version of this software soon, and I'll thank you very much. I'll thank every one of you. Thank you very much.